In the previous video on arterial blood gases, we looked at the differences between arterial blood and venous blood gases, the normal variables, and how to tell that whether the blood gas variables all match together. We looked at the difference between acidosis and alkalosis, and how to know the hydrogen ion concentration by calculating between the bicarb and carbon dioxide and matching it with the pH. Now we are going to talk about acidosis. The of the two disturbances in acid-base balance, acidosis is the far more important one. To say the least, alkalosis is also important, but it's not that commonly seen as much as acidosis. In fact, acidosis has got more complications and is of more clinical significance than alkalosis. Acidosis is divided into two parts. One of them is respiratory acidosis, and the other one is metabolic acidosis. And likewise, alkalosis also is of respiratory or of metabolic origins. A respiratory acidosis means that there is something wrong with the ventilation, and that is leading on to acid accumulation in the blood. Well, on the other hand, metabolic acidosis means that there is something wrong with the metabolism of the body, may it be with the liver or with the or with the kidneys, that is causing the accumulation of acids. If you if you want to know about different kinds of acidosis, it's a lot easier if you just remember the two variables. One of them is PCO2 and the other one is bicarb. But also, the thing to remember is the pH. Until and unless the pH is less than 7.35, you do not label it as acidosis. And unless it's greater than 7.45, we do not label it as alkalosis. So in order for an ABG report to be defined as either an acidotic or an alkalotic report, the pH it has to shift. Sometimes you do not have a shift in pH, but you do get abnormalities in PCO2 and bicarb. That could mean that this is either compensated, which is a term which you will often hear, that there is compensated metabolic acidosis, or there is compensated alkalosis. So let's see. If the PCO2 is high, that means it is greater than 46. If you remember, the normal value what we had was 36 to 45 on an arterial blood gas. If it's greater than that, then this is respiratory acidosis. If the pH is also less than 7.35. If the PCO2 is greater than 45, but the pH hasn't shifted, then we will not call it respiratory acidosis, but you'll call it that there is high PCO2 and there's accumulation of PCO2. So the person may be heading towards acidosis, or that this has been compensated for by the bicarb. So bicarb and PCO2, they are interchangeable. They both work hand in hand to compensate for the lost acids in cases of alkalosis or for the gained acids in cases of acidosis. And they both act together to bring the pH to the normal level. So when we talk about compensation, what we basically mean is that both of these act in harmony to bring the pH to within the normal range. Now, a very important concept which is often not understood clearly is the matter of compensation. Imagine if I gave somebody 5 coins without interest, that is, and this person has to give me back the 5 coins. Why would he give me back 6 or 7 or 8 when there was no matter of interest? So he will hand me back the 5 coins. So if I give 5 and he gave 5, so this is basically evenly compensation. So I've been evenly compensated. Or if he gave me something in return, but that amounted to exactly 5, then this is called as compensation. This is exactly what happens When the pH falls and there is metabolic acidosis, the body is going to compensate that either by blowing out PCO2 or by producing in excessive HCO3, which is bicarb, to bring the pH to 7.35. Now remember, when there is compensated acidosis or alkalosis, the pH has to be at the lower limit of normal. You do not get compensation with a pH in the upper limit of normal. This is very, very important concept. This, it will never be overcompensated, it will be compensated. So if you get a pH value of 7.35 and simultaneously you get a PCO2 value which is high, you know that this has been compensated. So this is a respiratory acidosis compensated for by the bicarb to bring the pH to 7.35. If the pH is 7.40 in this particular scenario, then obviously this cannot be compensated because it's been overcompensated. You do not overcompensate anything. You compensate that to the lowest possible denominator, and that is the lowest possible denominator. That's 7.35. So if that was the case, then this patient who is accumulating PCO2 still hasn't had a shift in his pH, still hasn't become acidotic, and so therefore we do not have any evidence of compensation. But this patient may be heading towards the acidotic side, so he will probably end up having respiratory acidosis. So what really happens is that in the lungs, this formula takes place. And in the blood, this formula takes place. So this is carbonic acid, and this happens in the lungs, while this happens with the liver. So in the lungs, H2O and CO2, H2CO3 is dispersed, is dissociated to form H2 and CO2, and CO2 is blown out. While in the liver, H2CO3, it breaks into H and HCO3. And this bicarb, this forms the main buffer, which is readily available whenever there is a problem with acid-base balance. And the excess hydrogen, this goes and it leaks out of the kidneys. And so therefore, this is how the acid-base balance is maintained. So you get excess carbon dioxide that is blown out and excess hydrogen that is removed from the kidneys. But when it comes to compensation, there are two kinds of compensation. One is a rapid and a quick compensation. This is usually in less than 24 hours. And then there is a slow compensation, which is after 24 hours. The rapid compensation is by means of HCO3, which is present in the blood. As you've seen that in both arterial and venous bloods, the HCO3 value is more or less the same because you need the same buffer in equal amounts both in the arteries and the veins. So therefore, it's not different. So the rapid compensation, that means that a compensation which is less than 24 hours, is by means of HCO3, and the other one in cases of acidosis is by means of PCO2. So PCO2 is actually blown out. And that's why in people who become acidotic, often, for instance, diabetic ketoacidosis or uremic acidosis, you see that they're hyperventilating. So when they're hyperventilating, they're indeed blowing out carbon dioxide. So in cases of metabolic acidosis, the compensation comes with these two. The slow compensation is always through the kidneys, and this is by excreting excess amounts of hydrogen. So that is the slow compensation. As a rule, for every 10 millimeter mercury increase in PCO2, the bicarb increases by 1 millimole. So say for instance, if you say the PCO2 being normal, for instance, you said this is 45 as being normal, and the person is retaining PCO2, and the PCO2 has gone up to say 65, so there is a difference of 20. So initially within the first 24 hours, there's going to be an increase of 1 millimole per 10 millimeters of mercury. So there will be an increase in bicarb with an extra 2 millimole. So if we take the normal bicarb, for instance, to be, say for instance, to be 24, this will be 26. If you take the normal one to be 26, this is going to be 28. So this happens in the first 24 hours. In the second 24 hours, which means the slow bit, for every 10 millimeters of mercury, the bicarb increases by 3.5 to 4 millimole. So, in other words, if you get an ABG report in which the bicarb is, say, for instance, 35, you know that X bicarb is being produced, and so therefore that would account to. So this is called as compensation. The whole idea is that with this excess bicarb which is being produced, you're once again normalizing the pH to 7.35. This pH will not be higher than that. It can be probably 7.36, but it really depends on the lab which is measuring it. But it will be at the lower end of the normal. So there we have it. So this is the whole concept of compensation, and I know that this is a bit tricky, but remember, compensation means that you're compensating for the lost acids or the lost alkalis. And if you're compensating that, you're compensating them to bring the pH within the normal range. Although we took 7.40 as to be the normal pH, and all of our calculations so far has been around the pH of 7.40, but we know the pH, the range is 7.35 to 7.45. So all of these compensation will be to bring the pH to 7.35. And using this formula, we know H2O plus CO2, this is what happens in the lungs, this is what happens in the liver, and the excess hydrogen which is in the circulation, this goes out through the kidneys, and so therefore you lose excess hydrogen and you'll bring the H2S balance into what you want it to be. And there are two kinds of compensation, rapid and a slow compensation. The rapid compensation is that which occurs immediately, and this is by means of bicarb and by PCO2. And so this is metabolic acidosis with rapid compensation. And if you look at the formula of this one, that this is how it works. And for respiratory compensation, we saw that for every 10 millimeters of PCO2 which rises, that is in respiratory acidosis, the composition is per 1 millimole. And we've got a slow compensation. So rapid compensation and slow compensation depends on how much carbon dioxide you blow out, how much hydrogen you're going to lose from the kidneys, and then how much bicarbonate is going to be manufactured by the liver. In the next video, we'll talk briefly about the anion gap. We'll talk about acidosis, different types of acidosis, and then how to approach a patient with acidosis.